We now discuss the solution of a problem from the section Matrices and Determinants. The problem is related to find the sum of powers of a given matrix. This question has appeared in the joint entrance examination main held on 29th June 2022 in the second shift. The given question is, let capital M be a 2 by 2 matrix whose first row is 0 minus alpha, second row is alpha 0, where alpha is a non-zero real number and capital N is equal to sigma k is equal to 1 to 49 of m power 2k if I minus m square in brackets multiplied by n is equal to minus 2i, then the positive integral value of alpha is, it is a numerical type question. We are given capital M is a 2 by 2 matrix given like this. Alpha is a non-zero real number and it is further given capital M is sigma k is equal to 1 to 49 m power 2k. It is also given I minus m square in brackets multiplied by n is equal to minus 2i, required to find the positive integral value of alpha. Let's now discuss the solution of the problem in detail. We have m is equal to the 2 by 2 matrix whose first row is 0 minus alpha and second row is alpha 0, where alpha belongs to the set of real numbers and alpha not equal to 0. Right. We'll now first find out m square. So m square is equal to m into m. After multiplication, we will get the 2 by 2 matrix whose first row is minus alpha square 0, second row is 0 minus alpha square. This is same as minus alpha square in brackets multiplied by I, where I is a 2 by 2 identity matrix. Agreed. Now, given n is equal to sigma k is equal to 1 to 49 of m power 2k. This m power 2k is same as m square to the power of k. So, sigma k is equal to 1 to 49 m square to the power of k, where m square is minus alpha square multiplied by I to the power of k. So, when you multiply this one, so you will get k times if you multiply I into I, k times is I only. So, minus alpha square power k into I. Agreed. Sigma k is equal to 1 to 49. So, this is the same as we have taken out this scalar outside in brackets sigma k is equal to 1 to 49 minus alpha square to the power of k in brackets multiplied by the identity matrix, right? And if you expand this one in the bracket, you will get when k is equal to 1, it is minus alpha square. When k is equal to 2, it is alpha to the power of 4. When k is equal to 3, it is minus alpha to the power of 6, etc., etc. When k is equal to 49, it is minus alpha to the power of 98. So this is all in brackets multiplied by I. Now we can take out minus alpha square common in this. So this will be equal to minus alpha square into in brackets 1 minus alpha square plus alpha to the power of 4 minus etc. plus alpha to the power of 96 because we have taken out a alpha square out. So multiplied by I, right? Minus alpha square into this one is a geometric series. It's a geometric series and whose first term is 1 and common ratio is minus alpha square. So the sum will be a into 1 minus r power n by 1 minus r. So it is minus alpha square into 1 minus r power n. R is minus alpha square to the power of n is 49. 49 by 1 minus r, that is 1 minus of minus alpha square, that will be 1 plus alpha square. So that is equal to minus alpha square into 1 plus minus 1 to the power of 49 is plus minus 1 minus 1 minus 1 plus 1. So 1 plus alpha to the power of 98 by 1 plus alpha square multiplied by I. Now we are given I minus m square in brackets multiplied by n is equal to minus 2i. We are required to find the positive integral value of alpha. Now let us see what is I minus m square. M square is here. I minus m square is I minus m square is minus of alpha square I, that is plus alpha square I. So I is common. 1 plus alpha square multiplied by I. So for this we write 1 plus alpha square multiplied by I into n is the above one minus alpha square into 1 plus alpha to the power of 98 by 1 plus alpha square multiplied by the identity is equal to minus 2i. Agreed. And this 1 plus alpha square, this 1 plus alpha square cancels and this minus cancels here, and equating you will get alpha square into 1 plus alpha to the power of 98 is equal to 2. So the identity will also go off, right? Identity inverse you can multiply on both sides. Agreed. So you get this equation in alpha, and it's a polynomial equation whose degree is 100. Anyway, whatever it is. So we required to find the positive integral values of alpha. So start with 1. So integral value 1. So alpha is equal to 1. If you take it, it satisfies. So 1 square is 1 into 1 plus 1 to the power of 98, 1. So 1 plus 1 is 2. 2 into 1 is 2, 2. So alpha is equal to 1 satisfies this equation. And any value of alpha greater than 1, which is a natural number, will exceed it 2. For example, if you take alpha is equal to 2, it is 2 square into 1 plus 2 to the power of 98 is certainly a big number which is bigger than 2. So alpha is equal to 1 only satisfies. So because we are required to find positive integral values, therefore the positive integral value of alpha which satisfies this equation is alpha is equal to 1. The positive integral value of alpha that satisfies this above equation is 1. So the answer to this question is 1. So that is the detailed discussion of the solution of the problem. From the section matrices and determinants, the problem is related to the sum of powers of a given matrix. And it is definitely an easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.